Right now, you are the loop. You type a task, you wait for an answer, you read it, you spot the mistakes, you fix them, and then you prompt again. You are the part in the middle that checks the work and decides what happens next. The best builders in the world just stop doing that. Within days of each other, two of the most senior engineers in AI said the same thing. Peter Steinberger said you shouldn't be prompting coding agents anymore. You should be designing loops that prompt your agents. And Boris Cherny, the head of Claude Code at Anthropic, said it from the inside. I don't prompt Claude anymore. I have loops running that prompt Claude and figure out what to do. My job is to write loops. 2 weeks ago, we covered why that went viral. This is the full playbook. By the end, you'll know exactly which loop to build and how to build one that runs for hours without burning your money or losing its mind. And this isn't hype. It is already how Anthropic builds Claude Code itself.
And we're now at the point where almost all of Claude Code is being written by Claude Code, and it can run effectively for days at a time.
So, what is a loop really? A prompt is a single instruction. You ask, the model answers, and it's done. A loop is different. A loop turns itself. You set the goal once, and the system finds the work, does it, checks it, repairs what failed, and keeps going until the result passes. Prompting gives an agent an instruction. Loop engineering gives an agent a job. Here's the old way that most people still use. You prompt, the agent answers. You review, you find the mistake, you fix it, and you repeat by hand. It works, but it doesn't scale because you are the bottleneck. The new way. You define the goal, the loop discovers what's needed, it plans the work, the agent executes, a checker verifies the result, the loop fixes the failures, and it stops when the goal is reached. Every good loop has the same 5 stages: discover, plan, execute, verify, iterate. If the output passes, ship it. If it fails, it goes back around. That is the whole idea. Not one perfect prompt. A system that keeps making an imperfect output better until it clears the bar. Remember that line because it's the thesis of this whole video. A reliable loop beats a perfect prompt. Loops come in 2 sizes. The first is a single agent loop. One agent runs the whole cycle. It figures out what's needed, plans, executes, checks its own result, and improves it. It's like one person rewriting their own draft. That's perfect for focused work. A bug fix, a research summary, a content draft. One brain, one loop. The second size is a fleet. Here you give one orchestrator agent the mission, and it breaks the work into pieces and hands those pieces to specialist agents. And each specialist can spin up its own subagents for the narrow jobs. Picture building a productivity app. The orchestrator owns the mission. Then a research specialist, an engineering specialist, and a QA specialist each take a lane. And under engineering sits a code writer and a debugger. That is not one agent working alone. It's a small team running a project end to end. So the obvious question is, when do you use which? Last week, Anthropic published the official map. Let's read it. Anthropic's blueprint is called Building Effective AI Agents, and it starts with the atom inside every system. Their words. An AI agent operates in a continuous loop. It perceives the environment, decides the next step, and acts to accomplish a goal. Perceive, decide, act, then look at the result, and go again. That's the engine. The simplest shape is the single agent, and this is the real diagram straight from the document. Input goes to the model. The model reaches tools through MCP, pulls from memory, and loads skills, then produces output, looping until the job is done. Anthropic's guidance on when to use it is blunt. Single agents shine on open-ended problems where you can't predetermine the steps because you don't know upfront how many you will need. When should you avoid one? When you need the perfect answer on the first try, every single time. And here's the line most people skip. Before you scale up to a fleet, ask whether adding skills to one agent solves it first. One of their customers, Augment Code, pointed a single Claude agent at a code base and finished in 2 weeks what their CTO had estimated at 4 to 8 months. One agent, aimed well, is not a small thing. Now, not every loop should be free to roam. Sometimes you want fixed rails, and that's what workflows are predefined loops. The first is sequential. Here's the real diagram. Each step feeds the next. Draft, then review, then polish. The win is predictability. You get a clean audit trail and the same behavior every time, which is exactly what you want for approvals and compliance. The cost is flexibility. A rigid chain is brittle the moment an edge case doesn't fit. The second is parallel. Here, independent agents work at the same time and you merge the results. This is the real financial risk example from the doc. A credit agent, a market agent, an operational agent, and a regulatory compliance agent, all evaluating one loan at once. Then a decision engine combines them. You reach for parallel when speed matters, or when several perspectives raise your confidence, like having multiple agents vote. You avoid it when the agents need to coordinate on shared state, because nobody is in charge of resolving the conflict. Now, the powerful ones. First, Evaluator-optimizer. Two agents in a loop. One generates, the other evaluates against fixed criteria and sends back specific fixes. And they cycle, usually 2 to 4 times, until it's good. Here's the real diagram. A generator writes API documentation, a technical evaluator checks it against the actual code, and they iterate until every check passes. Hold on to this pattern because it is the heart of the entire video. The maker is never the only grader. Then there's the full multi agent system, and it splits into two shapes: hierarchical, where a supervisor delegates to specialists and treats them like tools. This is the real marketing example: a director agent coordinating research, design, copywriting, and media planning. And collaborative or swarm, where agents talk peer to peer with no central boss, like this competitive intelligence team. Anthropic's own research found that on complex tasks that need many independent directions at once, a multi agent system with Claude Opus as the lead and Claude Sonnet as the subagents beat a single agent by 90.2%. But there's a catch, and it's a big one. Multi agent systems burn roughly 10 to 15 times more tokens, and the context can balloon past what one agent can hold, which is why the doc suggests capping responses around 25,000 tokens. So, which one do you actually build? Anthropic gives you a decision framework, and it comes down to three questions. Question 1: how much control do you need? If you're in a high stakes, regulated, audit everything world, start with a single agent or a sequential workflow because you can explain exactly why it did what it did. Loosen the control and hierarchical and then collaborative systems become viable. Question 2: how complex is the problem? A single domain, like answering product questions, a single agent handles fine. Multi domain, but predictable. Use a sequential or parallel workflow. Truly open ended. That's where multi agent earns its cost. Question 3: what are your resource constraints? A limited budget points you straight back to single agents or carefully designed parallel workflows. Because remember, multi agent runs 10 to 15 times the tokens. And here's the rule that saves you the most money. If you just need deep expertise, add skills to a single agent before you ever reach for a fleet. Start simple, earn the complexity. Here is the most important practical distinction in the whole space, and almost nobody leads with it. Loops come in two types: open and closed. An open loop is exploratory. You hand the agent a broad goal and let it find its own path. It's powerful because it can discover things you never specified. It's also expensive and messy. It'll try too many paths, burn tokens, and drift away from what you actually wanted. A closed loop is bounded. You design the path first. The loop still runs on its own, but inside clear rules, a defined goal, evaluation after each step, a stop condition, and a handoff point if it gets stuck. The closed loop is the version that pays off today. It's cheaper, it's more reliable, and it produces cleaner output. So the advice is simple: start with closed loops, open them up later once your checks are strong enough to trust. Which raises the real question: how do you build checks you can actually trust? That is the rest of this video. Most loops that fail don't fail because the idea was wrong. They fail because the loop can't tell whether it's actually done. And here's the trap almost everyone falls into: they let the agent grade its own work. Think about why that's broken at the level of the math. The model that just wrote a solution sees its own answer as the most likely thing to say next. So it systematically rates its own work too highly. That is not the model being lazy. It's a direct result of how it samples. An agent's self assessment is not a check, it's an echo. And this isn't just one blogger's theory. Here is Anthropic's own engineering team in their workshop on building agents that run for hours. So the rule is simple and hard. The thing that grades the work can never be the thing that made it. That check has a name: a deterministic oracle. Something that returns an exit code, not an opinion. A test that passes or fails. A type check, a linter, a build, a number over a threshold. Here's the simplest loop that actually works, and it's real code. A while loop runs the check, and if it's red, it asks the agent for the minimal fix, then runs the check again until it's green or it hits a limit. But look closely, because there's a non obvious decision baked into this. Every iteration starts the agent fresh, from clean context. Why throw away the conversation each time? Because models degrade as their context fills up. The instructions from the top get lost, and the model gets distracted by its own past turns. They call it context rot. So you keep the progress on disk, in the files, and in Git, not in the agent's memory. Each run reads the changed files and the failing test with a short, clean context. And one rule on that oracle: it has to be deterministic. Run your check 10 times on the same code. If it flickers green, then red, fix the check before you build the loop, because a flaky check destroys the stop condition. Now, the subtle failure mode. Give a loop one goal, make the test pass, and the agent will find the cheapest route to green. And often, the cheapest route isn't fixing the code, it's breaking the test. Delete the assertion, mock out the real logic, hard code the expected value. This is called reward hacking. And again, it's not malice. It's the optimizer doing exactly what you asked, exploiting a hole in your metric. The defense comes in layers. Writing, please. Don't weaken the tests into the prompt is the weakest one. The real defense is a check the agent can't reach. Make the test files read only, or add a gate that fails the run if the tests changed in the diff. That gate costs almost nothing, and it's always on. The strongest layer is a separate judge, running on a different model, that reads the diff and asks one question: did this go green because the code got fixed, or because the test got gutted? A model is bad at catching its own self deception, but good at catching another model's. Anthropic builds exactly this. And it raises one more question, the one their own engineers asked out loud in their workshop on agents that run for hours.
The obvious question for me, at least, is if the evaluator is also just an LLM, why doesn't it just rubber stamp it too? The evaluator here isn't just reading diffs, but it's actually using Playwright to open live pages, click around, try things out.
That's the answer. Their evaluator doesn't just read the diff. It opens the live app with Playwright, clicks around, tests it for real, and writes harsh critiques. The adversarial pressure is the entire point. Now, everything so far gets you a loop that converges once. To make it run for hours, you need a few more pieces. First, memory, because the model forgets the moment a run ends. But the repo doesn't. You keep a status file the loop reads first and writes last. A human readable log, plus the critical state in JSON. So the loop's logic never depends on how the model reworded its plan today. Second, and this is the one most people get wrong, handoffs. When a long run starts to lose the plot, the instinct is to compact the context and keep going. But Anthropic found that compaction doesn't actually fix the drift. Structured handoffs do.
So before the generator actually goes ahead and writes a single line, we have the two agents basically negotiate what done actually means.
Here's what that means in practice. A planner turns your one-line goal into a real specification. And then the generator and the evaluator negotiate a contract through files before a single line of code is written. The work is handed off cleanly, not smeared across one endless context. Third piece, isolation. A loop running unattended needs a blast radius. Give each agent its own Git work tree so they don't collide. Then go further and run the whole thing in a container with the network turned off. So a poisoned instruction hidden in some file can't reach out and cause real damage. Define the loop by what it can destroy, not just by what you want it to do. And fourth, breaks with observability. A hard cap on iterations, a budget cap per turn, a circuit breaker that trips if the same failure repeats, a heartbeat file so you can see it's alive, and a structured log, one JSON line per event. So when the loop dies at 3 in the morning, you can read exactly how it died instead of guessing. None of that is optional. That is the floor for anything you leave running while you sleep. Let's talk money, because this is where loops actually break people. Loops burn tokens fast. A single medium coding loop can use 50,000 to 200,000 tokens. A fleet with an orchestrator and several specialists can hit 500,000 to 2 million. A scheduled daily loop can reach millions of tokens a week. Every retry, every self-correction, every verification step, every subagent, all of it costs. And here's the part that breaks intuition. Cost is not linear. If your loop is stateful and rereads its whole history every turn, cost grows with the square of the iterations. That is the real reason you go stateless. A fresh context keeps each iteration roughly flat. The same task in braked hands closes for a few $100s of API. Unbraked, it can burn tens of thousands. The difference isn't the model. It's whether there was a real check and real limits. Loops die 4 ways. Runaway, where the bill climbs and nothing turns green. Silent death, where it hangs on a full context. Random walk, where it moves but never toward done. And the dangerous one, understanding debt, where the code ships faster than you can read it, and no log catches that one. Only your discipline does. Let's put it all on one board. Single agents. Best for focused, well-defined work. Cheapest to run. But they hit a ceiling on truly complex problems. Sequential workflows. Best for multi-step approvals and pipelines. Fully auditable, but brittle on the unexpected. Parallel. Best for speed and multiple perspectives, but weak when agents must coordinate. Evaluator-optimizer. Best for quality on nuanced output at the price of extra cycles. Hierarchical and collaborative fleets. Best for sprawling, multi-domain missions, the most capable, and by far the most expensive. And here's the thing, you don't pick one forever. Anthropic shows an e-commerce team's journey from a single support agent to routing, to specialized agents, to a full multi-agent system, to evaluator agents for quality, adding a stage only when the last one paid for itself. That is the North Star. Start simple, measure everything. Add complexity only when it earns its keep. And if this still sounds theoretical, it isn't. These are the numbers organizations are reporting with Claude-powered loops in production. Coinbase runs agentic systems against $226 billion in quarterly trading volume at 99.99% availability across dozens of internal AI applications. Intercom's Fin agent resolves up to 86% of support conversations. Inscribe cut fraud review time roughly 20 times over, from 30 minutes down to about 90 seconds. And Thomson Reuters put the expertise of over 3,000 subject matter experts into a single legal agent. This is the same loop you just learned running at scale. The only real question is whether you build one too. So here's the whole playbook in 3 breaths. 1. A loop turns itself. It discovers, plans, executes, verifies, and iterates until the work passes. And a reliable loop beats a perfect prompt. 2. Pick your shape with 3 questions: control, complexity, and budget. And add skills to a single agent before you ever build a fleet. 3. Make it converge with a check the agent can't fake, a fresh context every turn, a judge on a different model, and real breaks. And only then do you let it run for hours. I packaged every piece of this into one free field manual. The 3 question picker, the cheat sheet for all 6 architectures, the full convergence checklist with copy paste code, and the 4 ways loops die, and exactly how to stop each one. To get it, just comment the word converge, and I'll send it straight to you or grab the link in the description. If this leveled up how you think about AI, subscribe here on YouTube and follow Hyper Automation Labs on Facebook and Instagram because we go this deep every single week. And if you want to go further, the paid guides linked below are your next step. Now go take your most boring task, wrap it in one closed loop with a real check, and build the thing that builds for you. I'll see you in the next one. Next.